Hello game devs. In the previous video we talked about Perlin noises and how it's worked, but we didn't have any code at that video. In this tutorial we are going to create landscape like this or maybe this. But we don't make Perlin noise from scratch, we just use it. And the math class in Unity provide this function for us. We can just use Perlin noise here. So let's jump to code. Here at first we create an empty game object. This game object will create our world, and I will rename this to generator, and then I create an a script for it. We will need a prefab for our generator. So let's create a prefab for this. Let's create a folder called prefab and put this prefab here. Okay, so we have this cube here, and we will use it in our generator. Let's continue here in our code editor, and let's define some variables. At first I want to define the width and length of our world, so let me define. Then we need an scale for our noise, public float and noise scale. Okay, this will control the details that we have in our world. We need something to control our height. I call it height scale. So let's jump to create our function. I need an void function here, public void function, because we need to call it in other scripts. Generate. Okay, here we have width and length of our world. So we need two for loops to know the height of an specific cube in our world. As I told you before in the previous video about Perlin noises and how Minecraft makes its own world. Here I need two for loops, so let's create them. Int I, then I should be less than width, and then the other j less than length, and here j plus plus. Then here we are going to create our Perlin noise. Okay, as I said before, we are using math class here, so math Perlin noise. This function needs two parameters, the x and the y of our noise. Here we will use this I and j to these parameters. Okay, I pass these parameters here. Noise scale is something that controls our details in the world. So here I divide this to I, and then this function will create our Perlin noise. Okay, let's continue. This will be our height. Int height is equal to this. But this function return an float value, so we need to convert this. Use math dot float to int, and it will be okay. And now we have to have an access to our prefab, and so I create a game object variable here, and call it block prefab. Okay, then we have a for loop to fill our world, and like this: for int car 0 car less than our height. This function will fill our world from bottom to top of our world. Here we need instantiate function to create our game object, and this is our cube block. This is our block prefab. We have to pass an vector 3 here as a position, so we create this here, and vector 3 pose equal to new vector 3. The x of our vector 3 is our y, y is our height here, k, and the z is our j. Okay, so we pass in these parameters here, and then let's create this. We have an height scale here, and we have to multiply this to our height. Okay, but before testing we made a mistake here. This is j, this is j. Okay, let's double check here. Okay, everything is okay here. Let's pass the parameters here with, for example, 20 length, 20. Okay, let's test. We have something like this here. Let's change the noise scale, change it a little more. See, and when we increase our noise scale, the details will be more. As you see, when it was something like 1, it is just like a simple cube and with no details. But when I pass 10 here, we have a lot of more details. And let's increase these parameters here to see how interesting is this algorithm. Noise scale, 20 height, something like 50. Now see, here we have an massive Minecraft style world. This is really massive, and as you see, it completely killed the performance. And there is a lot of ways to make it better, but in this video we are not going to do them, and we are just here to make this world. But I want to mention some of them. You can, for example, just load the cubes that are visible for player. For example, when I'm looking like this, something that are behind the camera, behind the scene, they have to be invisible, and this make our performance really better. Okay, this is really boring, and I want to add some color to this world, but before that let's make it a little lighter. So let's start and colorize this world here, and when we instantiate our game object, we can put it into a variable called game object called cube, and then we can change the color of this cube. We get the mesh render, and then the material, and then the color, and then we set that color to for example red, just for test. All of our map now is red, but I want to do something different. I want these lower height places be for example green, and these places be gray, and this place on the top hills of mountains be white. Okay, how I can do this? We need something like this. If k is less than, for example, 0.2 multiply height scale, then I want this cube be green. Dot get component mesh render dot material dot color, and then green. And you can set other color if you want. You can set an RGB here to make an special color, but for this tutorial, just for learning, I set this green. Else, if it was greater than this value and less than, for example, 0.7 multiply to height scale, I want this to be gray. And else I want this to be white. And you got the point, and you can play with these colors here and colorize your own world. Let's see. Now we have a really better world, but it seems we had a mistake in our code. Here the green color is okay, but the white and gray colors here aren't okay. Let's see why. Here we can add line of code here if it was greater than or equal, and here we add equal here. Okay, let's now test. Okay, now everything is correct. Their color is cool, it's nice. I think we can add some more colors to it, and I want make this script better by an variable, a list variable here, to let us to add more colors. Okay, let's do this. Here I defined a list of colors called colors, and then instead of this if else here, I want to implement a different system to choose our color, and this is how I want to do this. At first I have to find what index I want to choose for a specific cube. I do this like this: int index is equal to, this is how I find the index. Here when our k value gets closer to our height scale, it means that we are in the top of our world, and then we will choose our last index of our colors. Or if our k value is a little number and it's far from our height scale, it means we are in the bottom of our world, and we will choose something like 0 or 1 of our colors, and then we just have to put this color to our cube. So now let's test our script. Here we have our colorist, and I want this to be something like this color, snowy hills of our mountain. So let's test. Just see how beautiful is our world now. We have a really beautiful Minecraft style world here, but see here we don't have any cubes, and we have to fix this. Let's jump to code, and this is because we floor this value to int. We have to save this to int. Okay, let's test it now. Now everything is completely okay. See how beautiful is this world. We can make it a little bigger. Our height scale something like 20. We add some more colors here. I want some lava, something like this color, lava. And then upper I want some rivers like this, a little lighter color, something like this color. I want the ground, some color ground. Look at this wonderful Minecraft style world that we just create with Perlin Noise. And I think it's enough for this video. I hope you enjoy your Minecraft style world here. I really love this landscape that we create here. So I hope see you in the next video, and goodbye.